Hi there, everyone. I hope you're all doing well, and I hope you're all excited for more of the 2006 Cayley paper, and we are on question number 15. Okay. In the multiplication shown, P and Q each represent a single digit, and the product is 32,951. What is the value of P plus Q? All right. So P is a units digit in a 3-digit number, and Q is a tens digit in a 2-digit number. What can we do here? Well, I think the thing to focus on, because if we remember how to do this sort of multiplication, if we remember how to do this, you get things like 1, 2, 3 times 7, 1. You have to take the 1 and multiply it by the 3, and then multiply it by the 2, and multiply it by the 1. Then you move over a digit, and then the 7 times the 3 is 1, and then you carry the 2, and so on. It gets quite involved, especially further on. But if we just focus on the units digit, there's always going to be a 0 here when we use the 7, and if we used a 2 in the hundreds digit and things like that. The units digit is determined exactly by the multiplication of our 2 units digits. And this is true not just for 1, 2, 3 times 71, but it's true in this case as well. So we have what? 39p Q3. Now I don't have any idea about Q. I don't need to. If I perform this multiplication, I'll get 3p. Maybe I'll have to carry something, yada, yada, yada. It all comes down here. And then when we start using Q, we move over, and then Q times P is something. Yada, yada, yada. And then it all adds up to 32951? 951, yeah. So where we get this 1 here is exactly the units digit of 3p. And this is pretty important, and it's going to allow us to solve exactly for p. Notice that 1, no matter what it is, if something ends with a 1, it's not even. So p is not going to be an even number, because you'd need to have odd times odd to end with an odd digit. So we ask ourselves, okay, p could be 1, 3, 5, 7, or 9. 3p would be 3, 9, 15, 21, 27. 3 is quite special in that only one of these has a 1 at the end. So what's going to happen is we're going to have p is equal to 7, and we'd get the 21 here, we'd carry a 2, and so on. And the whole calculation would proceed from there. Okay. So I know that p is equal to 7. Can I do the same sort of thing to get q? Well, maybe. It depends on what you mean by same sort of thing. Yeah, you could set up a series of equations and probably get q. But now that we know p is 7, we know that one of the numbers in our product is 397. Why don't we just grab our handy calculator or do some long division with 397 on 32,951, and we'll be able to get Q3 or QT3 as our response, as our division there. So we know that 32951 divided by 397 is equal to QT3. And just for the sake of not having to use my calculator as much, I'm going to try to do a long division. Okay. So 397, well, it doesn't go into 329, so we have to ask how many times does it go into 3295? And it looks really close. I'd say probably 9 times. That's my guess. I'm going to say 9 times. What happens when I multiply through? So 9 times 7, we get a 3, carry the 6. 9 times 9 is 81, plus 6, you get a 7 here, and then carry the 8. 9 times 3 is 27, plus 8 is 35. Okay, too much. And that's okay. So I'm pretty sure it's going to be 8 now. Well, that's 8 times 7, 6, carry the 5. 8 times 9, 72, plus 5, so 77. 8 times 3, 24, plus 7, 31. And now we can subtract. Need to borrow 1 from there. 9, 1, 1. Bring down the 1, and this should be 3. And we'll just double check to make sure I've done my calculation right. But if you're confident in your long division, and I do admit a calculator would have been much faster, I like doing long division because I don't ever really get to do it much anymore. 3 times 7, 1, carry the 2. 3 times 9 is 27 plus 2, so that's a 9, carry the 2. 3 times 3 is 9 plus 2. It all works out. So P is 7, Q is 8, P plus Q is 15. And yes, you could have gotten it much faster if you'd just broken out the calculator to do the division. No one's trying to say long division's faster. Alright, so that gives us an answer of C. And that finishes up question number 15. And we'll be looking at question number 16 in the next video. Thank you guys as always for watching, and I will see you next time.